Hey guys, Mr. Noon here with another awesome example with all this crazy free fall stuff. All right, guys, so I'm going to show you an example that kind of includes a lot of different things, and so let's get right to it. Now remember, what is free fall, right? So free fall is this idea that basically on the earth anyways, you are going to be falling at this constant rate once you find yourself without something underneath you to support you. And it only affects vertical motion. We've talked about that over and over. It doesn't matter how far you launch out sideways, your time in the air is going to be the same as if you just dropped from that point or launched out sideways. So it's kind of like, wow, are you sure? That's like counterintuitive, but yes. Yes, indeedy. That's the way it works. All right, so let's check out an example problem here. Let's say that you are, let's say that you are the owner to a couple of daredevil hamsters, right? And let's imagine that you are, you're walking along this 210-foot, cliff here, and here you are. And you're having a good day until you notice that that there is your hamster right here. Let's say he's on a ladder, okay, and he's right here, and then there's a fuse, and he's about to light a fuse, and that fuse goes down to the bottom of a cannon, and inside that cannon is your other hamster, and he's about to launch, he's about to blow this cannon. He's going to launch this hamster up in the air, and you're like, no, because this isn't good. But these hamsters, they're just daredevil. They don't know. They just think this is fun. Oh, so you don't get there in time. So okay, there we go. So there's the hamster. He's flying through the air, and let's say he has initial velocity of 35.5 meters per second, and that's typical. Like if you were to launch a hamster out of a cannon, that's about the average. So we're launching this guy out of here, and so you're like, oh no, and you think to yourself, how high is he gonna go? And you think, wow, how am I going to figure out how high? I already know that he's 210 feet off, but now he's getting launched straight up in the air. All right, well, let's think about it. When I get launched straight up in the air with a velocity, I am in free fall even though I'm going up, because gravity is going to be taking me down at a negative 9.8 meters per second squared. So gravity, that 9.8 meters per second squared in this situation is a deceleration, you see. It's a deceleration. And so what it's going to do is it's ended up going to go to a certain point up here, and it's going to bring it down to 0 meters per second. So that negative 9.8 is going to take that 35.5 down to 0 at the highest point, you see. And then it's going to start coming back down. All right, so we can actually figure out how high it's going to go. This equation right here, the velocity final squared equals velocity initial squared plus 2 times the acceleration times the displacement final. This is an equation that I gave you, but check it out. We can figure this out. I know that my velocity final up here is going to be 0, right, when it gets launched up. So I know the acceleration of gravity is going to take that velocity final down to 0 at the highest point. I know that the velocity initial is 35.5, right? So I got that squared plus 2. I know that my acceleration of gravity is negative because it's going to be taking that number down, right? It's an opposite direction acceleration. So always keep in mind whenever you're doing these free fall questions, like what's gravity doing? Is it taking it down, or is it speeding it up? So if gravity is going in the same direction as your velocity, well, then it's going to be positive. It's going opposite direction, like here. So I got my vector going the opposite direction. It's going to be negative. So I got my displacement final. So if you were to figure this out, and I'm going to save you kind of the time it would take to do it on the calculator, and you could do this, take a minute to do this. You could bring this over. Let's say we got a negative 35 times 2 times negative 9.8 times my displacement final. So I'm going to square that, divide by that. So my displacement final, if I do that, comes out to 64.3 meters. Okay, now I know I've got a total of 210 here, so my total height, right, my total height off the ground is going to be, I'll go plus my 210 meters, so I have 274 meters. Oh my gosh, that hamster is going to be up there. That's going to take, you're going to have to run down here, you know, and make him a little cushy bed of cotton candy or something so that he doesn't die. All right, so what if I was to say, well, that's great. I need to know how much time I need to get all the way down here. How much time am I going to need to get all the way down there? Well, we could easily figure that out. There's a couple different ways to figure that out. Let's go ahead and let's say, okay, oh, and maybe your final velocity. Let's do that too. So what about my final velocity down here? Like, how fast is he going to be going when he hits? And then how long do I have to get down here and set up a bed of cotton candy so he doesn't die? All right, so final velocity. Let's figure that out. We could easily do that because we know at the top here, I am going to be at 0 meters per second, and then I'm going to have gravity be increasing. So gravity is going to be now in the same direction, so it'll be positive, right? And down to a final velocity. So I got to use this same equation right here. I could say final velocity squared equals my initial velocity, which I know is 0, because I'm going to go from this point all the way down, plus 2 times 9.8. Now look, in this case, the acceleration is positive, right? Because I'm starting at 0, and I'm going to increase my velocity as I go down. So this time the direction of motion is the same as gravity, so it's positive. And I have times my total height here, which we already found out was 274. All right, do that right there. Do the algebra you need to on that, and you'll find out your final velocity is going to equal 73.3 meters per second. Wow, he is gonna be cooking. All right, that's pretty darn fast by the time he hits down there. So you're gonna need probably a decent sized bed of cotton candy for that one. All right, now how long do you have? Let's say, okay, I need to know how long I have to scramble down the hill and set this up. Okay, so if you start running down at the moment that he's launched, let's figure this out. We could use this equation right here. Final velocity equals initial velocity plus acceleration times time. We could figure out our total time right there. So I know my final velocity down here is going to be 73.3. Now, I need to define my direction. So my initial velocity is 35.5. I'm going to call that positive, and I'm going to call this negative. So negative 73.3. You could do it the other way around, but one of them has to be positive and one of them has to be negative for sure. Equals 35.5 was my initial velocity going up, plus my acceleration. In this case, my acceleration is going to be negative 9.8 because this is my positive direction, and so my acceleration is going to help my negative direction. So notice my two negative directions are matching up, so gravity is this direction for sure, and this 73.3 was that direction, times my time right there. Check that out. You go ahead and solve that, and guess what you're going to find out? You're going to find out that that you have a total of about 11.1 seconds, okay? So 11.1 seconds. I think that's plenty of time to get down here and set up. So, you know, your hamsters should be safe and they'll be on to their next adventure right there. So hopefully this helps you guys just to kind of see how versatile these things are and how you can do so much. Now there's actually probably a number of different ways to solve these things, and you could have used other equations, and of those 3 equations that I gave you, you could have used that second equation in there. You could have broke this up into other pieces and parts, but the part you got to do is you got to look at, you know, what are my directions? Is gravity positive here, negative? Is it going with the motion or against it? Setting that up that way also always is super important for these. So hopefully that was helpful, giving you guys a little bit of a lowdown on some of the stuff that we can do with free fall problems.